In numbers for A and B and C, which would give me a specific case, I can leave A, B, and C in there. If I leave this in ax squared plus bx plus c form, and I can rewrite this equation using mathematics, then I might be able to arrive at a certain formula that might have meaning. Maybe. And what is the great procedure that we learned yesterday, which I told you is like finding a favorite thing these days? Completing the square. So what we're going to do is we're going to try. You're going to help me because I forgot. I'm a little rusty. Should I say, but you're going to help me anyway. We're going to take this equation and we're going to solve this for x. We're going to leave a's, b's, and c's in there. It's going to be fun. So we're going to complete the square to do this. Okay. So when you complete the square and pretend that there are more numbers in there than there are, which right now, how many numbers are there? There's a 0. Hey, that's good. So how would you, if you were going through the process of completing the square, what would you do first? Subtract c from both sides. So let's do that. So that leaves me with ax squared plus bx. And then I would also insert some blanks, right? Maybe not yet. Plus bx equals negative c. Then what would you do next? Let's pretend that the a can be any value. So it can be 1, which would make us happy, or it can be anything else. So how would I get rid of it? Yes. So I'm going to divide both sides by a, which is going to look more complicated for a little while, but it's all going to make sense in just a couple of minutes. So I'm going to divide everything by a, which leaves me with x squared plus bx over a equals negative c over a. So this is not a can you do this on your own, this is can you follow it as I'm doing it. Okay. I want you to work too. Okay. Now that I've gotten the a out of there, now I'm going to complete the square. What do I need to do? Find half of b and then do that stuff. So I'm going to put some blanks in here. This is plus bx over a plus blank equals negative c over a plus blank. Now, what is half of b? Well, first, what is our b value? Our b value is the number in front of x, or the letters in front of x, which here is b over a. What is half of b over a? Go. What do we do to the bottom number again? We double it, right? When you multiply it by a half, it's like saying b over a. What is half of it? You multiply it by a half, and you get b over 2a. And then we place the x back at the end, because that was the value for b. So this becomes x plus b over 2a squared. Now actually take b over 2a and I square it. What is b over 2a squared? Well, what's b times b? b squared. And then what is 2a times 2a? 4a squared. And so this is b squared over 4a squared here too, because what I do to one side, I have to do to the other side. Okay, I've already dealt with all this stuff over here, so I don't have to really look at this anymore, because I dealt with this and this became this stuff, right? Just have to look at the right side of the equation. Can I combine these together? Negative c over a and b squared over 4a squared. Not currently, but can I rewrite one of these so that I could combine them together? Sure. What's the common denominator between a and 4a squared? Not a. what is the common denominator between a and 4a squared? You might be thinking of the lowest common multiple between them, but we're talking about the lowest common denominator. 4a squared is the lowest common denominator. A is the lowest common multiple. But I need to take this negative c over a and write it. I can multiply by something to make it 4a squared, right? What is that I need to multiply by? 4a over 4a. So that makes this negative 4ac over 4a squared. And then I still have the plus b squared, so I can write that all as one thing. Now on the left side, what can I do? What do I do in my process of completing the square now? Well, I take the square root, right? That makes this x plus b over 2a, because the squared goes away. And then on the right side, I could take the square root of all that stuff. Now remember when we take the square root of the fraction, you could take the square root of the numerator and the denominator? Which is good because what does the denominator become when I take the square root of 4a squared? 2a. So I'm just going to erase this. If that's okay with you. Even if it's not, I'm doing it anyways. And I'm changing this to 2a because I'm running out of space. Now, is the x alone? Almost. I just have to subtract the b over 2a, right? So this is the square root, and I'm just going to move these two terms around, switch them. B squared minus 4ac all over 2a. And now it's just a matter of subtracting the b over the 2a from both sides, and then I end up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula. Now, this year, the question is, can you follow along? Next year, the question is, prove it. This is a really elementary advanced proof, early on advanced mathematics kind of proof. And it's very important because we use this formula all the time. So it is important to be able to derive it on your own because you may forget it at some point in the future. Like I forget everything, and then I just go back to this and I solve it, and I arrive at it again. So now that you know the formula, now you can also know the song. But for this part, recording. So there's the quadratic formula. Does anybody know which part is the discriminant? Quentin?
A squared minus 4ac.
Oh, you were looking ahead, aren't you? Yeah, that's true. The part that is, the part that is the discriminant is the part that's underneath the radical. Why would that have significance? Well, remember, for a quadratic equation, how many answers do we always end up with? Two. Are they always real? No. So sometimes there are two real solutions, sometimes there's one real solution, and sometimes there are none. No real solutions, but complex solutions. This b squared minus 4ac part gives me a shortcut to finding out from an equation that looks like this, before I even try to solve it, whether or not my answers will be real or imaginary. Because if the value for b squared minus 4ac is positive, I'll end up with two solutions. If this value is 0, how many solutions do you think I'll get? 1. And if this value is negative, how many real solutions will I get? I'll get 0 real solutions, but 2 imaginary ones. Which ones? That one. At any time you can't see, feel free to find it out. I won't get it. Okay. We're still on, huh? Oh, there's the formula, which you already have written down, I hope. It's in your book, too. Now, there's one little caveat to this. A can't equal 0. So if A equals 0, why can't A be 0 anyway? Well, yeah, that is true in this form, but why is it not very probable for A to be 0 in ax squared plus bx plus c equals 0? What happens to the function when A is 0? Yeah, it's no longer quadratic. That's why A can't be 0, because then it becomes, in fact, a linear function. Okay. So, we'll do a couple of these with the quadratic formula. I'll show you how. One of the challenges to the quadratic formula is not losing your negatives and using your order of operations correctly. Also, to apply the formula, you need to have all of your equations in ax squared plus bx plus c equals 0 form. So, for example 1, what is the first thing I would need to do? Can you read that okay, or is it too small? Make it bigger. I need to subtract the 28 from both sides first, so that I have a 0. X squared minus 12x minus 28 equals 0. If you have to use the quadratic formula, I like to, it's a good idea, to write a little note to yourself on the right, just to say what the value for A, B, and C are. So what is the value for A? 1. The value for B, negative 12, because sometimes that negative gets lost. And then my value for C is negative 28. Now it's just a matter of writing down the formula, plugging it in, and simplifying. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There it is.
Please tell me you were
I was. Okay, then plug it in. Let's see if you could do this part. No, like the whole thing, Xander.
I did the first
one. So there are roots in the discriminant. I've already kind of hinted at this before. You can use the discriminant, which is the value underneath the root in the quadratic formula, to determine whether or not your answers are imaginary or real, and to determine how many of each you will have. So if you're asked, if I give you some kind of an equation like 3x squared minus 5x equals 1, and I ask you not to find the roots, but to tell me what kinds of roots there are, you don't have to use the entire quadratic formula. You can just use the b squared minus 4ac part. You would subtract the 1 still, right? Get it into standard form. But once you do that, you can use your little discriminant piece and just find the value for b squared minus 4ac. With a little practice, this becomes mental. And you can just look at this equation, equals 0, and you find b squared. That's 25. 25 minus 4 times 3 times negative 1. 3 times negative 1 is negative 3. Minus 4 times negative 3 is positive 12. So these are going to come positive. There will be 2 real answers, but there could be 2 imaginary answers. Or you can have 1 real answer that occurs twice. Remember we talked about that yesterday? Sometimes these quadratics can just touch in one place, the x-axis. So you would have like 1, 0 at 2, but there in fact 2 just shows up twice. So the equation for this might look like x minus 2 parentheses squared equals y, the equation for that graph. Which would mean that when you multiply all that out, the original form looked like x squared minus 4x plus 4 equals y. And if you use the b squared minus 4ac on this, you'll find that your value inside the discriminant is 0, because there's only one root. So b squared, 16 minus 4, 16 minus 16 is 0. So remember to keep making the connections between your equations and your functions and what that means graphically and what it means algebraically. Okay, here's a quick overview. This chart came right from your book. On the value of the discriminant and the graphs that correspond to them. I think we need to spend too much time on this because we talked about it already. If the value of the discriminant is negative, then you have two complex roots. So in the real xy axis, the xy coordinate plane, there are no x-intercepts, but we talked about how there are x-intercepts or intercepts in the complex plane. You just don't have the ability to graph that yet. We haven't talked about it. But it looks like in the real plane, there are no intercepts because there are no real answers. But there are two complex roots. You have imaginary parts. And when the value of the discriminant is 0, there's only one real rational root, but it occurs twice. It repeats. So when you factor this out, you get like x minus 2 parentheses squared, or x plus 5 parentheses squared. When it's positive, you can either have two rational roots or two irrational roots. The irrational part just means that you have like a radical of 6 and there a radical of 5. That's what irrational means, right? Versus rational, which is just a fraction like p over q, or 1/3. Or 5. It's 5 is just 5 over 1. Okay. Now the other part of this is like when you have a quadratic equation and you can solve it any way you want. So there are certain parts of the test where I'll specify, solve this using the quadratic formula. Solve this using factoring. But if I don't tell you which method, you can pick any method that's more convenient for you. Sometimes one method is better than another. Graphing is like the least effective method because most of the time, if you don't have whole number answers, it's really hard to find. You're going to have to estimate. And that's not very accurate. Factoring works well if you have something like x squared minus 3x equals 0. Because if I have something like x squared minus 3x equals 0, I could factor out an x, and that would give me my zeros very quickly. Could you solve x squared minus 3x equals 0 using the quadratic formula? Well, you could. Would you want to? No, because you would probably be wasting some time. You would still get the right answers, but it would just be a lot more work. So part of the skill is like being able to look at these and identifying if I have something that looks like x squared minus 3x or something you think can factor it first. See if it works. If it doesn't work, then go down the list. So I would definitely try factoring before you do anything else because it's so quick. Well, the quadratic formula and completing the square are very time consuming, though they're very accurate. They always work. So if you're not sure what to do when you're solving a quadratic equation, you know you can always complete the square or use the quadratic formula, and if you do the right calculations, follow the right algorithms, you will always get the right answer. Always. Always works. The square root property, that's where you take the square root of both sides. That sometimes works. So these two work sometimes, factoring in the square root property. Look for those two first because they're so quick. If those don't work, then choose. Do I want to complete the square? Do I want to use the quadratic formula? Some people like the quadratic formula more than completing the square. Some people it's the other way around. It just depends on what you like better. Questions about that? So on your assignment, you may be asked to solve something using the quadratic formula, or you may be asked just to solve it. If the directions just state solve, you get to pick whichever method is faster for you. Okay, that's it. Look at that. We did all that stuff and we finished.